And welcome back as we continue through our cosmic journey in our solar system. We, of course, have looked at asteroids and comets, but now let's go ahead and shift gears to that of meteors. So when we start talking about meteors, it's important to recall the term cosmic dust. The ices in comets evaporate when they get close to the sun, together spraying millions of tons of rock and dust into the inner solar system. There's also dust from asteroids that have collided and broken up that we can also find here. Now, the Earth is surrounded by this material. As each of the larger dust or rock particles enters Earth's atmosphere, it creates a brief fiery trail. This is often called a shooting star, but it is more properly known as a meteor. So, we can observe these meteors. Meteors are created as tiny solid particles that enter Earth's atmosphere from interplanetary space. Since the particles are moving at high speeds of many kilometers per second, friction within the air vaporizes them at altitude somewhere between 80 and 130 kilometers. The resulting flashes of light then fade out within a few seconds. These shooting stars got their name because at night their luminous vapors look like stars moving rapidly across the sky. In order to be visible, a meteor must be within about 200 kilometers of the observer. Now, on a typical dark, moonless night, another observer can see at least half a dozen meteors per hour. These sporadic meteors are random occurrences, and over the entire Earth, the total number of meteors bright enough to be visible totals about 25 million per day. Another way to kind of really think about meteors is as cosmic fireballs. The typical meteor produced by a particle with a mass of less than 1 gram is no larger than a pea. So, how can we see such a small particle? Well, the light that we see actually comes from a much larger region of heated, glowing gas surrounding this little grain of interplanetary material. Now, because of the high speed of the meteor, the energy in a pea-sized meteor is about as great as that of an artillery shell fired here on Earth. But this energy is dispersed high in Earth's atmosphere. If a particle the size of a golf ball strikes the atmosphere, it produces a much brighter trail, which we refer to as a fireball. A piece as large as a bowling ball actually has a fair chance of surviving its fire entry if its approach speed is not too high. Now, the total mass of meteoric material entering Earth's atmosphere is estimated to be about 100 tons per day. Now, of course, we have this other thing that some of you might know about, which is that of meteor showers. Many of the meteors that strike Earth are associated with specific comets. Some of these periodic comets still return to our view, whereas others have long ago fallen apart, leaving only a trail of dust behind them. The dust particles from a given comet retain approximately the orbit of their planet, continuing to move together through space but spreading out over the orbit with time. When Earth crosses such a dust stream, we see a sudden burst of meteor activity that usually lasts several hours in an event that we refer to as a meteor shower. Now, when we're looking at meteor showers, it's important to know a couple things about them. The first is the radiant. The dust particles and pebbles that produce meteor showers are moving together in space before they actually encounter Earth. Thus, as we look up in the atmosphere, their parallel paths seem to come toward us from a place in the sky which we refer to as the radiant. This radiant is the direction in space from which the meteor stream seems to be diverging. Now, it doesn't mean actually it's coming from that particular point in space, it's just where it appears to be, from Earth. Now, meteor showers are often designated by the constellation in which this radiant is located. For example, the Perseid meteor shower has its radiant in the constellation of Perseus. But you are likely to see meteor showers anywhere in the sky. It doesn't have to necessarily be locked to a particular constellation, nor even just the constellation of the radiant. Now, when we actually look at the meteor material, are they going to be closer to what we suspect from asteroids or from comets? Well, no shower meteor has really ever survived its flight through the atmosphere and been recovered for that of laboratory analysis. However, there are other ways for us to investigate the nature of these particles, and thereby gain additional insight into the comets from which they are derived. One of the ways is to do analysis of the flight paths of meteors, and it shows that most of them are very light or porous, with densities typically less than 1 gram per centimeter cubed. If you were to have a fist-sized lump of meteor material on a table on Earth's gravity, it might well fall apart under its own weight. Now, such light particles break up very easy in the atmosphere, accounting for the failure of even relatively large shower meteors to reach the ground.